Hi there, welcome back to another video. Let's jump into some examples with integration by parts. So it's kind of a new exciting tool that we can use now, right? There's more difficult integrals that we can evaluate that we couldn't before using this new method. So let's just do an example right here to start off. So let's take the integral of x squared times sine of 2x dx. Okay, this is our integral. So first we have to choose u and v. So let's refer to that table I had before. Lieti, liate, however you say it. This is logs, this is inverse trig, algebraic, trigonometric, and exponential. So, do we have anything in our equation that's logarithmic? No, we don't, because x squared is algebraic, right? Sine of 2x is trigonometric. Inverse trig, nothing there. Now, a is algebraic, and x squared is algebraic. So, remember in the last video I mentioned whatever comes first in this list, that is going to be your u. So right away, we know that our u is going to be x squared. So I'm just going to write here, u equals x squared, in which case du, right, that's just 2x dx. Okay, I'm actually going to write this a bit just to the right here. So if u equals x squared, then du equals 2x dx. Okay, so that leaves us with, after we kind of get rid of this x squared, we're dealing with the integral of sine of 2x dx. That's going to be our v. Okay, so our v is going to be the integral of sine, okay, of sine 2x dx. Okay, and just using our substitution rule, remember, this is going to be 1/2 of the integral of sine w dw if we let w equal 2x, right? Because then dw would be 2 dx. We have to add that half in there to kind of cancel it out. Okay, so just kind of touch up on your substitution rules there, but we're going to get, after we evaluate it, we're going to get that it's equal to negative 1/2 cosine 2x. And we're not going to worry about our plus c right now. All right, we're not going to worry about our plus c. And our dv, right, our dv is just the inside of what we're integrating. So our dv is just sine 2x. I keep having to move it over here. These equations are so long I don't want to run out of room. So dv equals sine 2x dx. Perfect, we got our dv, we got our v, got our u, and our du. Now let's go to town. Plug this stuff in. So we know that the integral of u dv equals the integral, or sorry, I'm going to write u times v first minus the integral of v du. Okay, let's just plug it in now. So we know our u is x squared. So the integral of u is going to be x squared dv. What is dv? That is just the inside of what we originally integrated. So it was that sine 2x dx. Right, that part there. That's going to equal u times v. Okay, well, u was just x squared, and our v was negative 1/2 cosine of 2x. So I'll write negative 1/2 x squared cosine 2x. Just bring that negative 1/2 out front there. Okay, and then what do we have next? We got minus our integral of v du. Okay, so v was negative 1/2 cosine 2x. Okay, and what was our du? Our du was 2x dx. 2x dx. So I'm just going to clean this up a bit on the next line. It's going to be the same stuff. actually, I'm just going to write equals because it's going to get a bit longer. So I'm just carrying this equal sign down over here. So negative 1/2 x squared cos 2x, right? And just to clean this up, negative and a negative, right? That's going to make a positive, so we can just say we're adding. We can bring this 1/2 out front, and also this 2. So see how this is 1/2 times 2 in the same kind of product there? Those 2's are going to cancel out, and we're just going to be left with plus the integral of 2x cos x dx on the inside there. Okay. Oh, actually, I made a mistake. That 2 is actually gone now. So it's just going to be plus the integral of x cosine 2x dx. And when you're doing integration by parts, always make sure that your integrals are getting simpler. Okay, so what we started with was x squared times sine 2x dx. Right now we have the integral of x times cosine 2x dx. So even though it looks pretty similar, we still have 2x kind of as our input for the trigonometric function. The x did go down a power, so it started with x squared, now it's just x. That means we're on the right path. And like I said, sometimes we're going to have to do this twice. That's just kind of the nature of integration by parts. Okay, so now that we have kind of a new set of things to deal with here, we got to do this process again. So we're going to have to do integration by parts twice here. We got to go through our list. Remember our LIATE, right? So do we have anything that's logarithmic? Nope. Inverse trig? Nope. Algebraic? Yes. We do have that x there. We do have that x there, so that is going to be our u. So we're going to say u equals x. Okay, that means du is just going to be dx. And we're going to say, well, our dv is just the other stuff, so cosine 2x dx. And our v is going to be the integral of cosine of 2x dx. Right, going to be the integral of cosine 2x dx. So let's think about this here. Now we can kind of plug this stuff in, doing integration by parts twice, so that's negative 1/2 x squared cos 2x. And since we're adding this integral here, instead of calling this integral the same thing, we can just call it the integration by parts version of it, which is u times v, right? So our u is just x, and our v, let's just see here, the integral of cosine 2x dx, that's just going to be 1/2 sine 2x, right? Just kind of your substitution rules. Okay, so x times, I'm actually going to write this 1/2 out front. 1/2 x sine 2x, right? And then we're subtracting the integral. Right? We're subtracting the integral of v du. So minus the integral. Our v is just 1/2 sine 2x. And then our du is just dx, so that's perfect. We can just fit that in there. Okay, so a couple things we've got to deal with here. I'm going to rewrite this. The stuff on the left is just the same, 1/2 x squared cos 2x. A lot of times with integration by parts, you're kind of carrying the last steps down. It's just like one thing you're changing. It's a little bit annoying and redundant, but sometimes it's necessary here. So we're going to bring out this 1/2 times the integral of sine 2x dx. Okay. And when you integrate this, right, using your substitution, you're going to find that it's going to be this 1/2 out front times another half again. So you're just going to get, like when you integrate positive sine 2x dx, you're going to get negative 1/2. You're going to get negative 1/2 cosine 2x dx. So I'm not going to write all this again. I'm just going to write, instead of minus a half out here, it's going to be plus a quarter. Sorry, I'm running out of room. These questions are just pretty crazy here. Plus a quarter cosine 2x dx. And last step, don't forget that plus c. So we're always putting that plus c at the very end. We're not worrying about it until the very end here. And this is, even though it's unbelievably disgusting to look at, this is going to be your answer for the integral of x squared sine 2x dx. So it's not pretty by any means, but it is correct. And yeah, so that's the first example that we can kind of do there. Moving on, let's do another one. Instead of going through another mess like that again, I want to show you another benefit of knowing how to do integration by parts. So lots of times we see this function ln of x. In calculus and algebra, it comes up all the time. People know how to take the derivative of it, right? People know how to take the derivative of anything. So d over dx, ln of x, that's just 1 over x, right? We all know that. We've seen that lots of times. Okay, but if we have ln of x, what if we're integrating it now? People kind of go, oh, hold on. I know how to go the other way and differentiate it, but how do I integrate ln x dx? Well, even though there's only one thing here, you can integrate this by parts. You can figure this out by using integration by parts. So what you do is you think of the dx here as 1 dx. So you think of this imaginary one as kind of being there for you to compare to the ln x. So what you do is you think of your acronym, right? LIATE. This is logs, this is inverse trig, algebraic, trigonometric, and exponential. And you say, are there any logs in this equation? Yes, there are. Ln of x, that is going to be your u because it comes first in this list. So you're going to say u equals ln of x, and haha. Now we can use our knowledge of differentiation and say, okay, since our u is ln x, we're going to have to differentiate that. That's why we chose it, is because we know how to go the other way. We don't know how to integrate ln x, so that was why it was our u. Now we know dv, right? We know dv is just going to be dx, right? We know dv is going to be dx, and v is going to be x, because if our dv was just this dx term here, if we integrate dx, we're just going to get x back. All right, so now that we know what our u and v are, du and dv are, we can plug this into our integration by parts formula. So integral of u dv equals uv minus the integral v du. I heard a song, it was like, roses are red, violets are blue, integral of u dv equals uv minus integral v du. It was kind of cringy, but that's honestly how I remember it sometimes. So just remember, remember this formula here. It's not too hard to remember because this uv, you don't have to worry about any integrals or anything, so that's always nice. But we're going to set this up and just plug it in. The nice thing about integration by parts is that it really is a formula, right? It doesn't change. So as long as you know your u and dv's, you're going to be all good. So integral u dv is just integral ln x dx. And that's just what we're trying to do, right? The left side here is always going to be just what your question is. And then u times v, that's going to be x ln x. Okay, the integral's gone there, so that's good. Minus the integral of v du, well, v is x. Du is times 1 over x, and that's my bad, I forgot the dx here, so this is going to be 1 over x dx. Well, would you look at that? If we simplify this, right, we're going to get x ln x minus the integral. What's x times 1 over x? So this is x over x dx, and x over x is just 1, assuming x isn't 0, so this is just the integral of dx. right? This is just the integral of dx, and dx, the integral of dx is just x, because this is like an imaginary 1 here, like I was saying. So your answer is just going to be x times the natural log of x minus x, and remember we got to have that plus c there. Okay, so the integral of the natural log of x dx is equal to x times the natural log of x minus x plus our constant there. Okay, so a little more difficult than just differentiating it and knowing it's 1 over x, but we can use integration by parts in many different situations and circumstances, right? We didn't even have two numbers multiplying here. We just had ln x, and we had this dx here, so we knew that ln x was in our acronym here, LIATE, in our acronym, it came first because it was ln, right? It was a log. So we called that our u, and whatever is left over that's multiplying into ln x, that's just going to be our dv. And we can literally solve equations using integration by parts that have one thing in them inside the integral, the integrand. So it's just kind of another application. I'll probably do another video or two on even more advanced problems using integration by parts. Sometimes you can have to use it like 3, 4, even 5 times just to get your answer. And there's different techniques that we're going to use. I'm not sure how I'm going to fit it all on this screen here because it can get pretty ridiculous. But yeah, I'm looking forward to it, and I hope you got something out of this video. I'll see you in the next one.